Consider a stunning cosmic concerto performed by an infinite number of stars, moons, and planets working together perfectly. However, in this celestial ensemble, one particular section has captivated astronomers for a long time. These natural worlds are called exoplanets, planets beyond the solar system, hidden deep within the Milky Way's vast expanse. You might be surprised to learn that, among the numerous celestial bodies, there lies an exoplanet so strikingly similar to Earth that it has every chance of being our planet's twin. Let's travel into this fascinating world, Proxima B, a planet that lies just 4.2 light-years from Earth. The James Webb Space Telescope is changing the way we approach the search for and comprehension of these mysterious worlds. Take a moment to imagine your thoughts exploring the enormity of a galaxy the size of the Milky Way containing more than 4 billion exoplanets. One is followed by 15 others. To represent this idea, imagine the size of each exoplanet as a grain of sand. This would not only fill the Grand Canyon, but it would be enough to build a brand new geological wonder on Earth. A Grand Canyon 2.0 is 4 meters long. Even more remarkable is that approximately 20% of these Earth-like worlds have been identified as geologically and atmospherically similar to our own planet. That means, for every 5 exoplanets, one could be another Earth. But this is not the end of the story. These planets could be accompanied by another billion rocky moons similar to Earth's own, engaging in a gravitational dance with their parent planets. If you want to discover a space body that could be home to life, the universe provides endless possibilities. Now that we've begun to spread out across the vastness of the cosmos, it's time to showcase the master artists capable of creating intricate celestial paintings, the James Webb Space Telescope. A cosmic investigator that, instead of a magnifying glass, holds a telescope lens shining above everything else. Its sophisticated optical devices, such as its primary mirror, which is 6.7 meters across, 2.7 times greater than Hubble's, permit it to detect the tiniest flickers of stars and analyze planets billions of light-years away. But James Webb is groundbreaking, not only for its unrivaled ability to observe, but also for its cutting-edge technology. It includes infrared sensors and spectrographs. These instruments don't just watch, they analyze the unique light signatures emitted or reflected off celestial bodies to decipher atmospheric conditions, density, composition, and mass. Acting like space forensic scientists, they can determine whether a planet has water, oxygen, organic compounds, or even signs of life. The James Webb Space Telescope is more than just an upgraded version of Hubble. It represents a colossal leap forward. If Hubble's discovery surprised you, prepare for an even more stunning sequence of revelations as we proceed through the intricate terrain of the universe. Our attention is drawn to one star in particular. Since its discovery in 2016, Proxima B, an enigmatic planet, has become the protagonist of a cosmic tale filled with paradoxes and complexities that have captivated astronomers and researchers. What sets Proxima B apart? To begin, it is located in our cosmic neighborhood only 4.2 light-years away. To put that into perspective, if you could travel at the speed of light, you'd reach Proxima B in just over 4 years, the same amount of time it takes for a presidential term to end, or for your favorite TV show to get old. But this planet's proximity is significant for more than just practical reasons. In a universe that stretches over 93 billion light-years, discovering a planet so close and so ripe for scientific exploration is like spotting a diamond in a mountain of stones. This gem may contain vital information about life and our place in the cosmos. Proxima allure isn't just its proximity. Astronomers believe that it might not just resemble Earth, it could even be Earth 2.0. Located in the so-called habitable zone of its star where the temperature is just right. Not too hot and not too cold, it offers the possibility of liquid water. Imagine waterfalls plunging down vast cliffs, rivers meandering through alien landscapes, and oceans as dark and mysterious as the Mariana Trench on Earth. However, before we let our imaginations drift into vacations on Proxima B, we must take its peculiarities into account. For instance, a day on Proxima B lasts about 11 Earth days. Imagine an astonishingly slow sunrise signaling a new day, followed by a prolonged sunset extending into glorious hours. For photographers, this may seem like a dream come true, but it also raises intriguing concerns about the planet's climate and habitability. How would we adjust our biorhythms to the new light cycle? Would we need to eat more during the long, dark phase? Could we sleep the same way? Proxima B might feel both strangely familiar and eerily alien, a riddle wrapped in planetary mystery. Its potential civilization, if any, could be similar to ours, or not at all. Proxima B challenges our assumptions about what makes a planet habitable. But how do we gather reliable information about a world we've never visited? The answer lies with the full power of the James Webb Space Telescope. Abilities to respond to this question, serving as an adaptable research facility in space due to its cutting-edge technology that allows astronomers to examine and observe distant planets with advanced equipment, spectrometers and infrared sensors. The emitted light can be studied with a telescope and is reflected off these otherworldly worlds by examining the particular wavelengths of light that are absorbed or released by various compounds or elements in a planet's atmosphere. Scientists are able to carry out a remote examination of these celestial bodies. This enables them to determine the densities of the atmosphere and the potential presence of vital elements, such as water, molecules, and oxygen. The James Webb Space Telescope isn't just another tool for observation. It gives us access to an analytical genius one. It's capable of turning speculative ideas into advancing our understanding of science, expanding our knowledge of the universe, and transforming our perception of what might exist beyond our planet. At just the right time when we thought we had figured out all the secrets of the end, cosmos researchers using the James Webb appeared to capture an extraordinary outcome. A strange signal from Proxima B it swept through, sparking debate between the academic world and social media regarding the possibility of life from other planets. Unlike other electromagnetic emissions, this one was nothing like anything previously observed. So intricate, so seemingly designed that it suggested the presence of a sophisticated civilization. For a brief moment, everyone's heartbeat appeared to become entangled in the possibility that we aren't the only ones in the universe. But just as quickly as it appeared, the signal went out of sight, leaving behind a surge of speculation and a list of unanswered questions. Was it just a brief flaw in the fabric of space? Or maybe it was a whisper from a far-off intelligence, possibly ciphertext, or even the sound of an ancient civilization spreading its influence across time. This one signal has cast Proxima B in a thick shroud of mystery, transforming it from a mere candidate for habitability into the center of cosmic intrigue. The possibilities are thrilling. Could this be a component of a more complex narrative one that binds us to a broader galactic network or community? While certainty remains elusive, it is evident that this mystery strengthens our resolve. It fuels more than curiosity in science. It sparks a profound desire to connect with someone, or something beyond ourselves. And the narrative does not end there. Given the advancement of technology, the James Webb Space Telescope is now more than just a celestial observer. Instead of being a passive sleuth, it is undergoing adaptation by forward-thinking researchers. It's no longer just galactic night vision. Equipment. Their goal is to examine distant exoplanets for more than signs of life in the absence of artificial illumination. Yes, cities have streetlights. Imagine cities that shine like alien twilight. Imagine how astounding it would be to witness an alien civilization buzzing with energy, not visible by its biological indicators, but by a skyline's technological signature shining across the dark side of an exoplanet. Artificial light, sounding like a beacon in the void. It may sound like science fiction, but it's rapidly becoming scientific fact. A discovery like this would be historic. Detecting artificial lighting would not only confirm the existence of intelligent life beyond Earth, would imply an interconnected universe in which life follows a pattern, not an anomaly. A cosmic song that plays over and over in the stars, and what implications would that have for us? It would alter religion and philosophy, science and politics all in one astonishing moment. We would no longer be Earth's desolate children, but a part of a vast, possibly ancient galactic lineage, It would prompt additional inquiries more profound than any we've ever asked before. What can we learn from them? And how do we define ourselves after we are also known? But for the time being, we remain near the edge of the James Webb Space Telescope's gaze. It continues to direct our attention deeper into the night. Star systems are revealed, environments studied, long-buried secrets uncovered. Every new spectrum, every silent transmission from space decoded, and every light curve studied brings us closer to answering the final questions. Are we the only ones out there? Or might we one day call another world home? This is more than just exploration. It is revelation. As we approach the cliff edge, let us not forget this extraordinary era. Let us not ignore the fact that the universe is not just vast, it is alive with unsolved mysteries, and with the James Webb Space Telescope illuminating our path, we are not just observing. We are discovering one world, one star, one signal. Into the future.